Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parvin. In this class, we are going to discuss last part of modern physics based on Hstr syllabus. Till now, I have made 4 classes on modern physics, part 1, part 2 and part 3a and part 3b class. Now this is going to be the part 4a class on modern physics. And part 4b class will be the last class for modern physics. Okay, so I will have to make another class to finish modern physics. Okay. Before starting the class, I want to remind you all, please do subscribe to my channel if you have found my channel just now and if you are watching my class for the first time. And who are already subscribers to this channel, all the teacher recruitment aspirants, Hstr, GPSTR, TET and all such competitive examinations, please do share my classes based on physics and mathematics among other aspirants and your friends for more such free video classes. Okay. And this will be a free class. So I am posting this in a YouTube channel as free class. But notes, of course, the notes will be provided to the paid class aspirants. Okay. So let us start the class. In the previous 4 classes, including part 3a and 3b, we have discussed all this entire syllabus which we have underlined. Atoms, constituents of atom and their properties, atomic number, mass number, nuclear chain reaction, nuclear fission, fusion and applications, and then elements which possess radioactivity. And also we have discussed the concept of alpha, beta and gamma decay and half-life and mean life period, and problems based on this also has been discussed. And then we have also discussed what are isotopes, isotones, isobars, and of course we have also discussed the atomic models, namely Rutherford's model, Bohr's model and Thomson's model. In this class, I am going to discuss the rest portion, mass-energy relation, mass defect and binding energy and problems based on these topics. Who doesn't know this equation? E is equal to mc square. I don't think any other equation is as famous as this one. I am sure that every one of us are familiar with this E is equal to mc square. But then I am also sure that many of us doesn't know the actual meaning of this equation E is equal to mc square. Actually, what this equation says is that energy and mass are the same. This was formulated by Albert Einstein in 1905 and he explained how energy can be released in stars and nuclear explosions through this equation E is equal to mc square. Now this theory which expresses this fact that mass and energy are same and this mass and energy can be changed into each other is called Einstein's theory of special relativity. Now in this E is equal to mc square, E is energy and m is mass and c is the speed of light. But then E is not just energy, it is kinetic energy of the body. And m is not just mass, it is the increased relativistic mass of the body. So I hope you have understood now that before starting this class, we need to understand what is relativity. Because before relativity, all other theories viewed this mass and energy as two different entities. But now, Einstein says that mass and energy are same. They can be interconverted to each other. Now to understand the concept of relativity, I have a short story from the very famous pair of Akbar and Birbal. But the story is not very famous. Okay. When I learnt about relativity for the first time in my life, at that time I had read this story. I learnt theory of relativity for the first time, I think before some 17 or 18 years. Okay. So I had read it in one textbook. It was a famous textbook of engineering, I think. But that book had all physics, right from basics to the higher class, till engineering level. All physics was there in that book. In that book, last chapter was a special theory of relativity. So the chapter only started with this story. So what happened one day? This famous pair of Akbar and Birbal, they were going for a walk somewhere, and then Akbar got some mischievous thought in his mind, and he wanted to do some mischief with Birbal and trouble him by asking him such a tough question such that he will not be able to answer that question. But we all know how Birbal was, right? He was very witty, he was very wise, and he was very much intelligent, right? That's the reason why Akbar liked Birbal so much. So Birbal had answers to all type of tough questions, logical questions, illogical questions, odd questions, even questions, all type of questions he used to answer. So this time Akbar got this mischievous thought and he asked him a question. There was one bamboo stick fallen there in that place in the garden or somewhere they were walking. So he showed that bamboo stick to Birbal and he told, can you make this stick shorter without chopping it? Okay, he told that, can you make this bamboo stick short without cutting it? You cannot use axe and all, you shouldn't cut only. Without cutting, can you make this stick short? After hearing the question, Birbal thought for a while. He looked around that place and he saw one gardener who had one bamboo stick which was lengthier than the stick shown by the Akbar. So what he did, no, he lended that bamboo stick from the gardener. He requested the gardener and he took that bamboo stick from him. Then he put this stick on the ground which was given by the Akbar. No, he put it on the ground, he laid it down and then he took the lengthier stick and he put it beside this stick. Then he told Akbar, now please look at this stick. He told this to Akbar. Then he told, your stick now looks shorter. So wise he was, right? See, you also agree with me, right? See, this was the stick given by Akbar. Okay, he laid it down, that Birbal, he laid it down on the ground and then he kept this longer stick beside the given stick. Now which is shorter stick? Now this is short, right? This is the shorter stick and this is the longer stick. Now which one is short stick? This is the short now. Without cutting that bamboo stick only, Birbal showed Akbar that the stick is shorter. But then if I say that this stick is short, my sentence will become incomplete, right? This stick is short relative to this stick, correct? Let this one be stick 1 and let this be stick 2. Now stick 1 is shorter relative to stick 2. You get my point, right? See, if I want to make stick 2 also shorter, what I will do? I can place another lengthier bamboo stick here and then I can say that this stick 2 is also shorter. Correct? Now if this is stick 3, then stick 2 is shorter relative to stick 3. Correct? So this concept is known as relativity given by Einstein. I hope that this concept is clear now. Okay. Now another concept which we need to clear in order to move ahead towards E is equal to mc square is a frame of reference. Frame of reference. Actually, this concept, no, I have taught very nicely in dynamics chapter. But dynamics chapter has been scheduled for a paid class students, so I cannot post it in the free YouTube channel. Anyway, I will explain you frame of reference here so that you will understand the concept. Okay. One is a theory of relativity which we have understood. Now we will learn this frame of reference, then we will move ahead towards E is equal to mc square. Now in order to understand frame of reference, let us take this example. A train is moving on the railway track. Inside, two people are there. One is this girl named Vincy and another is a boy named Tim. Okay, and another man is standing outside the train. Maybe he is standing in the platform or something like that, and he is a Greg. Maybe he is father of Vincy. Maybe he has come to drop her in the railway station. Okay, now Vincy entered into the train and she started walking in the corridor of the train to reach towards her chair. Okay, now her chair is this. She want to sit here. Okay, now she will be moving now. She came into the train and she is moving like this. Now, see from the perspective of Tim and Greg. If Tim and Greg are watching Vincy walking down this corridor of the train, then what will be the Vincy's velocity with respect to Tim? Vincy's velocity with respect to Tim is nothing but Vincy's velocity with respect to the train, because train is moving. Okay, this is a moving train. I should have told it, right? So the train is moving. Now Vincy's velocity with respect to Tim or with respect to train will be different, and Vincy's velocity with respect to Greg will be different because Greg is standing on the ground. So velocity with respect to Greg or velocity with respect to ground will be different, right? If you see from Greg's perspective, because at that time your frame of reference will become ground. What is Tim's frame of reference? It is train itself, right? Tim is watching from inside the train, so his frame of reference is train itself. And what is Greg's frame of reference? It is ground. He is watching Vincy from ground. Okay. Even Tim's velocity with respect to Greg also will be different, because Tim's velocity with respect to Greg is nothing but Tim's velocity with respect to the ground. Okay. I hope you are understanding. Basically what I mean to say is, from where you are standing and observing thing is your frame of reference. Okay. But that thing may be a moving thing also. It can be a moving body also. Okay. So the place from which motion is observed and measured is a frame of reference. In that example, Greg's frame of reference was ground. Tim's frame of reference was train. Okay. They two had two different places from where they were observing. Okay. So according to Tim, Vincy was moving. Only Vincy was moving according to Tim, because he is in the same frame of reference as Vincy was there. But according to Greg, Vincy is moving in the train, right? So according to Greg, Vincy and train both are moving. So velocity has so much changed for Greg because he is standing on the ground. There are two different places, right? So the place from which motion is observed and measured is known as a frame of reference. That object may have different velocities relative to different frames of reference. That object could be Vincy. Okay. Now this was about any object. I cannot apply this rule to speed of light. Okay. This is the actual point where we wanted to reach through relativity and frame of reference. The point is that unlike any object, speed of light does not change with any frame of reference. Okay, speed of light in free space is having the same measured value for all observers, regardless of motion of source or motion of observer. So speed of light is always constant. For example, speed of light is flashed by some space station, you think. Now that light is measured to be speed of light c. Okay. Now this is measured by the observer on both the space station and rocket ship. Okay, you can see the rocket ship here, right? Even the person sitting in the space station will also observe the velocity of light as c only. Okay, and the person sitting in the rocket who is having some different velocity, that person is also seeing the velocity of light as c only. Okay. So the moral of the story is that speed of light c is constant and it is approximately equal to 3 into 10 to the power 8 meter per second. Okay. Now I believe that the hero of E is equal to mc square is speed only. Because we are telling that E and M are same, right? Energy and mass are same, we are telling, and we are also telling that they are interconvertible. Then who remains? In E is equal to mc square. C only remains, right? So that is speed of light, which is constant. Now when we talk about a moving object, we say that the object is having kinetic energy. But if that object or that particle is at rest, then it will not have any kinetic energy, right? We know, right? Kinetic energy is the energy possessed by a moving object or a moving particle. But if the particle is at rest, then it is having no kinetic energy. But according to Einstein, it doesn't mean that the particle has no energy. Einstein says that the particle at rest is also having some energy. We call it as a rest energy. Rest energy. Okay. The concept which Einstein presented was that it takes energy to make some mass, and that energy is released only if the mass is disappearing. So the amount of energy will be related to amount of mass. Okay, this is related with the most celebrated equation, E is equal to mc square. In fact, it is being celebrated even now also. You will find it anywhere. Even in movies also you will find it. Even in some drama series also you will find it. Even in some film dialogues also people are using E is equal to mc square. Okay, this E is equal to mc square and Newton's third law. For every action there is equal and opposite reaction. These two, they are not at all from physics nowadays. You can find them anywhere, in any movie also, in any dialogue also. Okay. So these are the celebrated equations, I feel. Anyway, now he put forth this E is equal to mc square thing, and he told that energy is needed to make some mass, and energy will be released only if that mass is disappearing. Now, which is the remaining term from E is equal to mc square? It is a c square, right? So this c square is the conversion factor between energy units and mass units. Because see, if I write E is equal to mc square like this, I can clearly understand that E by m is equal to c square, right? So this together, this term should be equal to c square in case E is increasing. Now my aim is that this term should be equal to c square. What I will do? I will decrease m. Correct? In case E is decreasing, but I want to make this term equal to c square, right? So what I will do? I will increase m. So totally together E by m should become c square. For that, if E is increasing, m should decrease. Or if E is decreasing, m should increase. Only in this scenario, I can equate this E by m is equal to c square. Correct? Only in that scenario it is possible, right? Now we know that value of c is 3 into 10 to the power 8 meter per second, right? If I do square means it will become more double, right? It will become double. So the value or magnitude of c is large. In this situation, we are telling that this is equal to E by m, right? So if there is a small mass, in case there is a small mass, then E will have the enormous value. It means that the energy is enormous. So any particle which is having very small mass will have enormous energy in it. Okay, that is what E is equal to mc square tells. I hope you are understanding. You should have understood three concepts now. What are the three concepts? First concept is that E is equal to mc square is there, where E and m are same and they are interconvertible. Second concept is that because E by m will become equal to c square, in that situation, if E is increasing, m should decrease, or if E is decreasing, m should increase. And third point is that because the value of c is very much large, in that case, if the mass of the particle is very much less, then the energy will be enormous in that particle. Okay? I hope you are clear. Now this Einstein's theory of relativity, it got its name because it is describing how measurement of space and time are different for observers which are moving relative to one another. Now the example which we took of a stick, there nothing was moving. That was just a concept of relativity. But you can see the example of frame of reference. There you can see that the observer Greg, who was standing outside, had a different perspective when he was watching Vinci. And the observer Tim, who was inside the train, had a different perspective. Okay, here you can see how measurements of velocity and time, they are different from observers who are moving relative to one another. Okay, Greg is not moving, but then he is standing on the planet, right? And the planet is moving, correct? Now these things can be applied in space also. Not only velocity and time, even in space also. In fact, the larger concentration about the theory of relativity is being focused in space and time only. Okay, but that is a next level study and it is not there in our syllabus, so we will not get into it. Okay, only thing which we should know is that relativity is telling us that mass is a measure of rest energy. Till now we thought that only the particle which is having kinetic energy will have mass, because kinetic energy is equal to half mv square, and there is energy means there is mass, and there is mass means there is energy, we thought. But relativity is telling that if the particle is not moving also, the particle will have energy, and that is known as rest energy. Now this rest energy you denote it by E0, and rest mass you can denote it by m0. Okay, now this is measured in its rest frame. See, we are telling that the mass of the object is m0. Okay, it is rest mass. The energy is also rest energy, and the object which is not moving, no, it is in the rest frame because it is not moving. So rest energy should not include kinetic energy. That's what I told you earlier also, right? And another important point is that this nuclear fission and fusion is there, no? We have studied it, right? We have studied it in modern physics only. So this nuclear fission and fusion, we have seen that there was enormous amount of release in energy, right? So that was happening just from a small amount of mass, the atom. The atom you can say is having negligible mass, such a small mass, correct? But the energy released was such enormous that even bombs can be made using that atoms. So that concept of an enormous release of energy is according to E is equal to mc square. Okay, so nuclear fission and nuclear fusion is producing enormous release of energy, which is all in accordance with E is equal to mc square. Okay, this can be asked as a MCQ. See, every point which I am discussing in this class is very, very important and can be asked as a multiple choice question. Of course, I will be discussing many expected multiple choice questions also in this class. But then it's better that you watch class carefully, because any line can be made as MCQ. Okay. So because nuclear fission and nuclear fusion are obeying E is equal to mc square, I can say that the nuclear energy is nothing but E here. Okay. So this E is equal to mc square is synonymous with nuclear energy. Okay. I hope it is clear. Now what is the unit of energy? We commonly use electron-volt, right? In atomic and nuclear physics, the unit of energy is electron-volt, EV. E is small letter, V is capital letter. But what is this EV? How much kinetic energy the charged particle is gaining when it is accelerated through some potential difference of magnitude 1 volt. Now this charged particle can be plus E or minus E. I mean to say that the charged particle can be electron or a proton. So if you are placing that electron or a proton, and if you are accelerating it through some potential difference, and the magnitude of this potential difference is 1 volt, in that situation, how much kinetic energy that proton or electron is gaining is nothing but your electron-volt. Now because you are telling that potential difference is having magnitude 1 volt, then you can say that the energy is 1 electron-volt. Okay, because you are placing one electron in the field and you are placing it in the 1 volt field. So you can say that the energy it is having is 1 electron volt. Okay. Now we already know from electronics chapter, I think. Yeah, in electronics chapter we have discussed about the volts and the potential difference also. So in that class also we have discussed about the definition of 1 volt. This is equal to 1 joule per coulomb, right? But then we know the charge of the electron is 1.6 into 10 raised to minus 19 coulomb. So our 1 electron volt can be the product of a charge of electron, which is 1.6 into 10 raised to minus 19 coulomb, into, again 1 volt is 1 joule per coulomb, right? 1 joule per coulomb. See here, I will write and show you. I told that 1 electron volt is equal to electron into volt. Okay, it is 1 volt. Now what is the charge of electron? It is 1.6 into 10 raised to minus 19 coulomb is there. Now what is 1 volt? This 1 volt is nothing but 1 joule per 1 coulomb, right? So that I will write it here, 1 joule per 1 coulomb. My coulomb will get cancelled and my 1 electron volt is nothing but 1.6 into 10 raised to minus 19 joule. Okay, in terms of coulomb, if you want to see the charge of electron, it is 1.6 into 10 raised to minus 19 coulomb. If you want to convert 1 EV into joule, then it is 1.6 into 10 raised to minus 19 joule. Okay. But this 1 EV is a very smaller unit. Okay. If you have a larger amount of energy, you can use a kilo electron volt or you can use a mega electron volt also. Okay. So this is the larger unit of energy. Kilo electron volt. Kilo means you know it, right? 10 raised to 3 EV. MEV, mega electron volt. 1 MEV means it is 10 raised to 6 electron volt. What was the smaller unit? It was a 1 electron volt. Okay. So these are all important. They can ask as a MCQ. Okay. So this was all about your electron volt. Now let's come back to our concept which told that mass and energy are interconvertible. Practically, if you imagine, you will not get this point, right? So I will give you example. Whenever you have some mass, it means that you are having lot of energy sitting in that mass. But how much energy is there in that mass? So you can give this energy by E is equal to mc square, where m is mass. This will be in kilograms. You have to remember that mass is always in kilograms and E is equal to mc square. And c is velocity of light in vacuum, which is approximately equal to 3 into 10 to the 8 meter per second. Now this 3 into 10 to the power 8 meter per second is not a small value, right? It is 300 million in SI units. If you want to just tell it in terms of words, then it is 300 million. If you square this, you will have one huge number, right? It will become 9 into 10 to the power 16 meter per second. We will square it because it is there in equation, correct? The E is equal to mc square formula, you have c square. This actually didn't tell you, right? So this equation is famously known as a energy mass equivalence. Okay, it is famously known like this, energy mass equivalence, or E is equal to mc square also you can say. But then if in question, if they are giving this phrase energy mass equivalence, you should understand that they are talking about E is equal to mc square. Okay. Where were we? We were talking that if we square this, you know, it will become 9 into 10 to the power 16 meter per second, right? So it will become huge number. Now let us analyze this with one small example. Let's take one small marble. It is having just a 20 gram weight. When you convert this 20 gram completely into energy, then you can get same amount of energy as is released in explosion of a 500,000 ton hydrogen bomb. Because so much small mass means so much high energy will be there, right? That is what we saw in E is equal to mc square. We told that E upon m is equal to c square. So c square is very huge value. If mass is very small, means energy should be very high. Enormous amount of energy should be released. Now if you take the example of this marble, then 500,000 ton hydrogen bomb explosion should be there. But are you scared of this marble? No, right? We aren't afraid of this marble. Why? Because it is very difficult to release the energy which is present in that marble. Okay. Now there is some practical example to show how energy is converted into mass. That is what we are telling here, right? We are telling that mass and energy are interconvertible. We are telling. Practically, yes, one example is there and it is a famous example. You call it as a pair production. This is a practical example to show that energy is converted into mass. Here in pair production, what happens? No, energy is converted into mass in form of a separate and independent particle. Now that one particle, if it is an electron, I will write it here, electron. If this is one particle, then there will be another antiparticle. This is a particle. You will have an antiparticle. You call it as a positron. It is opposite of electron, you can say. Okay, so this can be asked as a MCQ. The antiparticle of an electron is a positron. In simple words, what is pair production means when some photon is incident on nucleus, then two other particles are formed from that nucleus. One is electron and one is positron. Okay. Now this incident photon, it can be a gamma ray, or in fact it will be a gamma ray only, because gamma ray is the one which is neutral, right? So this photon is also neutral. That photon is falling on the nucleus, and then you will find that that nucleus is emitting one electron and one positron. This is known as pair production, because a pair of a particle and antiparticle is produced, right? That's why it is known as a pair production. Now when photon is incident on this nucleus, the formation of electron and positron takes place, right? That's what I was telling. And as calculated by E is equal to mc square, the energy of photon should be at least 1.02 MeV. If the energy of photon is less than 1.02 MeV, here this photon, if it is less than 0.2 MeV, then this pair production will not happen. So the energy of incident photon should be at least 1.02 MeV. This is the value of the photon's energy. Unless and until this condition is fulfilled, pair production will not happen. Okay. So this can also be asked as a MCQ. And then the positron which is formed, no, here one electron and one positron is formed, right? So this positron is E plus. I told you it is opposite of electron, right? So one positron and one electron is formed. In that positron is formed, no, that will again disappear by combining with some other electron which is present in the environment. This process is called annihilation of matter. Means annihilation of matter is opposite of pair production. I'll tell you again. Before that, just note this point again, that pair production can only occur if the incident photon energy is at least 1.022 MeV. Okay, or 0.2 MeV is also okay. Now let's see what is annihilation of matter. Basically it is opposite of pair production. That positron which was there, no, that positron will combine with some electron, one positive and one negative. It should give neutral only, right? This should get cancelled, right? So your response should be neutral, right? So neutral means photons or gamma rays. Okay. So here in annihilation, you can see that electron and positron will combine together to form a photon. That electron is from environment. Okay. Now it can also be called as reverse process of pair production, as I told you, because in pair production, photons will split into electron and positron, and in annihilation of matter, electron and positron will combine to form photon. They both are opposite process, you can say, or reverse process, you can say. Another important point is that in annihilation process, low energy electron will combine with low energy positron. Then that combination will form a photon. Okay, so in this process there is also liberation of energy, that you should know. Okay, now this electron, no, this is having low energy, and positron is also having low energy. They are combining together and forming photon. Okay, So this is known as annihilation of matter. Now these are the equations. You never know. Anyway, this is next level only, the equations, but then I thought that we will not take risk. Okay, because they are not mentioning pair production in this syllabus, but then pair production and annihilation is the best example given for E is equal to mc square. Normally that is the best example. So I thought I will not take risk. See, pair production means this equation. We saw that one gamma ray will fall on a nucleus and one electron and one positron is released. Correct? And annihilation means one electron and one positron together, again they will release photons. Okay? What all we told in sentences, no, that is written here in the form of equations. Okay? So no need to worry. These equations, I hope that your concept is cleared by now. Okay? Now to conclude this mass energy relation, we told that mass and energy are interconvertible and we told that E is equal to m naught c square. M naught is the rest mass of the particle. Okay. Now if you want to substitute all the values here, then what will be the value of the energy? That I will tell you. See, E is equal to m naught c square, right? Now the mass of proton in terms of atomic mass unit or AMU is just 1. Okay. The mass of proton in AMU is 1, but in terms of kg, the mass of proton will be 1.726 into 10 to the power minus 2 kg. Okay, so the energy equivalence to 1 AMU will be given as E is equal to m naught c square, and here m naught value will be 1.66 into 10 to the power minus 27 kg, because we are taking mass in E is equal to c square as kg always. Okay. Of course, it is the mass of 1.66 into 10 to the power minus 27 kg is equal to 1 AMU. Okay. This also you should remember. C though we know is 3 into 10 to the power 8 meter per second. Correct. Now if I substitute these values here, this will be equal to 1.66 into 10 raised to minus 27 into 3 into 10 to the 8 whole square. Now this will give us 1.494 into 10 to the minus 10 joule. But if I want this in terms of electron-volt, then what I can do is I can divide this value by 1.6 into 10 raised to minus 19 joule. Correct? That is what we have learnt now in the definition of electron-volt. So if I divide this 1.494 into 10 to the power minus 10 by 1.6 into 10 raised to minus 19, I can convert this joule into electron-volt. So this is equal to, if you calculate it, you will get approximately, this is equal to 931 MeV. Some decimal point also will be there, 931.5 or something like that will be there. So what is important for us is not the calculation, not the method, just the value. This E is equal to or approximately equal to 931 MeV. This is very, very important. In fact, in E is equal to m naught c square, if the mass of the particle is very much negligible, then you can neglect it. Correct? At that time, in that situation, your E will be equal to c square, right? But what is E? E is equal to 931 MeV. So in many cases, we use directly the value of c square also as 931 MeV. So not only E is equal to 931 MeV, even in many situations where you want to neglect the mass, where it is very, very small, at that time, you can use synonymously the value of c square also as 931 MeV. Okay, this will give you shortcut method while solving problems. Whenever you are using E is equal to m naught c square and you want to substitute the value of c square when it is equal to E, you directly write 931 MeV. Okay, so this is very, very important. I will explain you this even in problems also. Okay, so I hope that you are clear till now. Actually, I thought that I will finish this class in one session only, but it is taking a longer time than expected while explaining. So the class will become very lengthy. So what I am going to do is I will stop the class now and very soon I will post the next part. So I will make this part of lecture as a part 4a, and the next part I will make it as part 4b for modern physics, and in the next part, I mean to say in the part 4b, I will surely finish this modern physics chapter. Okay. And before signing off, I want to remind you all, please do like, share and subscribe to my channel for more free classes, because if there are many aspirants who are present in my channel as subscribers, then maybe in future I can give more important classes based on Hstr syllabus for both physics and mathematics. Okay. Okay then. Thank you. All the best. Bye.